optimization problem. Make a box without a lid that will give the maximum volume from a sheet of A4 paper. Suppose you were in a packing company that made boxes. What you would want to do is make the maximum volume for the smallest amount of surface area for your product to be a good seller. Now the dimensions of A4 are 297 millimeters by 210 millimeters. So here's a sheet of A4 paper, and here is actually the finished product. This actually does give the maximum volume. Right, most people will probably then draw on the A4 piece of paper and then try to cut out 4 squares, because we're not interested in flaps in this problem. Okay, and then we'll cut these out and we'll fold up the edges to make a box. So if we make each of these lengths be x, these be x, the length here is 297, the length here is 210, then the length from here to here is going to be 297. Take away this x, take away this x. So it's going to be 297 minus 2x. And similarly, this one's going to be 210 minus 2x. Right, if we draw a box out, then this length is 297 minus 2x. This length here is 210 minus 2x. And this length is x. The top of the box is open, there's no lid on this box. So the volume will be the length times the width times the height. So that will be x times 210 minus 2x times 297 minus 2x. Now what we can do, this is a function of x, so I called it volume of x, v of x. We can draw this using autograph or our graphics calculator and find the maximum or minimum that way. So if we draw it, so this is the function. If we draw it, and this is one that I drew before, then you have to be careful. You have to make the axis much bigger than you anticipate that it should be. So you should go with the x-axis to 200 and the y-axis from about minus 200,000 up until 1,400,000. Now this is big because we are using millimeters in the question. Alright, so when you first draw it, you should forget any negative x, because you can't really have any negative x. You should use the zoom function of autograph. And then you should select the graph and then solve for f dash of x is equal to 0. And this will give you a maximum point here at value of x of 40.42. And this gives you the y-coordinate. So the y-coordinate here actually gives you volume. Okay, and you actually get another point down here, which is a minimum point, okay, which we're going to talk about in a minute. So the maximum is going to be 40.42. The maximum volume will be 1,128,000 millimeters cubed. Now that's doing it just using the graphical method. However, if you were going to use this for a project, what you would need to do, you would need to actually do this with a little bit of calculus, so that it actually has an advanced mathematical technique in it. So, if we've got v of x is equal to 210 minus 2x times 297 minus 2x, then we need to multiply out these two brackets first of all. So if we do that, we're going to get x, 210 times 297, which is 62,370. 210 times minus 2x, which is minus 420x, and then we do minus 2x times 297, which is minus 594x, and then we have to be careful. Minus 2x times minus 2x will give me plus 4x squared. So these two terms can be added together in the middle to get here 1014x. So we're going to have 62,370 minus 1014 and 14x plus 4x squared times that x in the middle. Taking that x in will give me 62,370x minus 1,014x squared plus 4x cubed. This will allow me now to differentiate the function. So differentiating, and because we're using function notation, when we differentiate, this is v dashed of x. So bring the 1 down, get 62,370, and here we bring the 2 down, so we're going to get 2,028 to the power x to the power 1, and then 3 times 4 gives me 12x squared. Now to solve this for maximum minimum, we have to put f dash of x equal to 0. So that's going to give me 62,370 minus 20.28x plus 12x squared is equal to 0. Note that gives you 12x squared minus 2028x plus 62,370 is equal to 0. Now we can now use our calculator to solve this using the algebra, the menu algebra solving for polynomial roots. Okay, you should know how to do that by now. So there's a screenshot of what we've done. Okay, and again that gives me x is equal to 40.4, and we got this other one, 128.6. Now this is a screenshot of what we got on our calculator when we did it. Okay, so before you could do it, it must be written this way round on the calculator. So you're entering 12 minus 2028 plus 62,370 as the coefficients of the quadratic. Should know how to do that by now. Note that 128.6 is not possible because the width of the original piece of paper was 210. So 2 lots of that will actually take it outside the width. Therefore, this was not possible. So now what we need to do is to show algebraically that 40.4 is a maximum. So check to see if x is equal to 40.4 is a maximum or minimum. So we do that, we take the first derivative, which was this, 62,370 minus 2028 plus 12x squared, and therefore we get x is equal to 40.4, x is just less than 40.4, and x is greater than 40.4. So here we have 40 and 41. At this particular point we know that the gradient is equal to 0. So what we do is we take 40 and we put it into this function here, and all we're interested in is to check whether it's positive or negative. When we put it in, we will find that it is positive. And then we take 41, which is just after 40.1, and do the same thing. If we put it in, we will find it's negative. So here we have a positive, 0, and negative. So this is a maximum point. So x is equal to 40.4 is a maximum. Find the volume of the box when x is equal to 40.4. So v of x will be x times 210 minus 2x, 297 minus 2x. We substitute 40.4 in, like that. Okay, and we get the answer rounded off to 4 significant figures, 1,128,000 millimeters cubed. Okay, if you do it on the graphics calculator, as long as you make the axis really large, like we did here. Okay, so it's from 0 to 200. So this is 4 times 10 to the 5. Okay, and this is 1.4 times 10 to the 6. So it's 1,400,000, and this is 400,000. Okay, so you should recognize what that means on your calculator, and then you can use the maximum minimum function to actually find it on the calculator, which you should be able to do by now. Okay, so we get x is 40.4, the same information, yeah? Okay, this has been rounded off here, 1.13 times 10 to the 6. So this is only correct to 3 significant figures. Okay, so going back, this is the finished product. Okay, and finally, there's the box. So if we put the box in, and put 40.4 into the dimensions of the box. The box has to have dimensions 216.4 times 129.2 times 40.4 millimeters. That's the dimensions of this box here. This is the actual size, which will give the maximum volume. Okay, and finally we have some happy students who have actually sat down and made their boxes for us today.